For our next lesson, we're going to talk about a time period called the Scientific Revolution. This scientific revolution takes place in Europe primarily during the 16th, 17th, and 18th centuries. There is a big movement which kind of defines the scientific movement away from asking the church, or the church very often would get their answers from ancient Rome or ancient Greece, primarily Aristotle. They would answer questions that way if people had questions about nature, about life, about the way things worked. People would go to the church, and the church would very often default either to the Bible or to ancient Rome or Greece. During the 16th, 17th, and 18th centuries, people begin to emphasize this idea of reason. They would find the answers to things based on their observation of science and what was taking place around them. They would systematically look at problems and answer questions to those problems based on what science was telling them. So the time of scientific revolution was when people would look for answers, not so much through the church, but they began to look for answers to nature through reason and through scientific observation, as we largely do today. There were 5 theories or 5 discoveries that took place during this time that revolutionized people's thinking about the natural world. The first one was a Polish man named Nicholas Copernicus. Copernicus comes along and he introduces what is called the heliocentric theory. The heliocentric theory was the theory that the sun, rather than the earth, was the center of our solar system, and that the earth, as well as the other planets, revolved around the sun. Okay? Which was very different than what people had thought before. They thought before that there was a geocentric theory, which was that the earth was the center of the solar system and that the sun went around the earth. It's very logical that they would think that, because from standing on the earth, it looks very much like the sun does revolve around the earth. In fact, we still say things like the sun is rising in the morning, when in fact the sun is stationary and we are the ones going around the sun. How did he figure this out? He figured this out through scientific observation and through reason, not through just things that had been accepted for thousands of years at this point. The next major thinker was a man named Kepler. Johannes Kepler comes along and he talks about planetary motion. And he says all of the things that Copernicus said are in fact true. The sun is the center of the solar system and the planets do go around the sun. But what he noticed as he looked out, again through scientific observation, he noticed that the planets actually moved in ellipses, that they weren't actually moving in perfect circles, but that they were moving in almost what would be like an oval type of pattern as they revolved around the sun. Okay, ellipses. So he is known primarily for his studies of planetary motion. Planetary motion, okay, the planets go around the sun in what are called ellipses. Our next great thinker is someone you've probably heard of before. His name was Galileo Galilei. He went generally by Galileo. And what he is going to do, among many other studies that he did during his life, is he is going to invent a telescope. He is not the first person to invent a telescope, but he does make a telescope that people can look up into the planets and see what's taking place. Okay? Look out into outer space and see what's taking place. And so basically the importance of his telescope that he invents is the fact that with this telescope he looks up and sees what both Kepler and Copernicus had been attempting to prove in the years before. Along with Galileo comes a man named Isaac Newton. Isaac Newton is going to revolutionize thinking about science. He's going to totally change things. People believed for a long time that the earth was in one specific sphere. So in other words, if this is the ground that a person is standing on, that there were certain rules of earth, okay, like that if you dropped a ball on earth that it would fall, okay, and then there were certain rules for outer space. So the sun and the moon and the planets had their own rules, and that was why they never fell to earth. That they were in one sphere and that the Earth was in another sphere. Okay? What Newton comes along and says is that that's not true. He says gravity, or the pull that two bodies have towards each other, is actually universal. That what takes place in outer space is exactly what takes place on the Earth, and the only thing that affects the pull of gravity is the distance between two objects, or the overall mass of either one of those objects. That's just a very confusing way of saying that gravity is universal. So this man, Isaac Newton, came up with this universal theory of gravity. People always represent Isaac Newton by drawing an apple, and that is largely because there is this old tale that he was sitting under a tree and an apple actually fell on his head, and that is what made him start thinking about this idea of universal gravity. Our last discovery or major thinker is a guy by the name of William Harvey. Harvey is actually the only one of these 5 men who is going to make observations not in the area of physics or in the area of astronomy, but rather his ideas come from the medical field. And what he is basically going to say is that human beings have a heart, which people had known long before. You can feel the heart thumping away in your chest. But what he said basically is that human beings have a heart, and that heart acts as a pump, and what it basically does is circulate blood through the rest of your system. And so it revolutionized or changed the way doctors looked at the human body and looked at treating the human body, and it became the basis for a lot of the different discoveries that are eventually made in the medical field. So William Harvey is going to discover that blood actually circulates through the system, bringing from the heart oxygen to the rest of the system. What does all this mean? Okay, if we summarize real quick, we say that the church basically, in this scientific revolution, the church went down in importance for answering people's basic questions about nature, and that science and observation of what was going on around them went up. And then we talked about what the major discoveries were. If we step over to this way, you can actually see that there were several important outcomes of all of this. The first is that there becomes a big emphasis in the world on reason. In other words, if somebody says something is true, like the sky is blue, right away we look for the reason in that. What is the reason the sky is blue? We know today it is a reflection of the oceans. Back at that time, people would make up answers for things that they didn't quite understand. Okay? How do we know that? We know that because of a systematic observation. We go through and we do all kinds of experimentation and so on through, which is what is actually our second outcome, through the scientific method, where we have a hypothesis and then we have a problem and then we make our observations and so on. We gather all of our data and we draw up conclusions. Okay, that's what we mean by systematic observation of nature. So there's this new emphasis in the world on reason, okay, and on systematic observation of nature. Also, in that whole process, we develop what is called the scientific method. It is no longer acceptable to just say that something is the way it is because God made it that way. It is important that if you believe that as a matter of faith, that's okay. But it is important to be able to systematically observe and explain that through the scientific method, which is why you do the scientific method in your biology classes and in your science classes in general. And the last, of course, is just that we have this huge expansion of scientific knowledge. As you can see over here, people start viewing the world in a very different way. They view the world not as the center of the solar system, but as one of many planets that go around the sun. Okay? And we start looking at the way that that happens. We start coming up with tools and ways to actually observe that. And we make huge leap forwards in our understanding of both physics and, with Harvey, biology. This whole time period is called the scientific revolution.